You hear about AI learning all the time, but what does that actually look like? For something like the Nova browser, it's not just one single thing. No, it's a whole sophisticated system that works a lot like a brain, carefully turning raw digital experiences into reliable, useful knowledge. And that gets us to the billion-dollar question, doesn't it? The internet is a messy, chaotic, constantly changing place. So how on earth can an AI learn from it without its brain just filling up with digital junk? Well, it turns out Nova's entire learning architecture is built to solve that exact problem. The solution is this really elegant three-part system. The best way to picture it is as a journey that every piece of information has to take. It starts out as a note in a diary. Then it has to pass a super strict quality control check. And only if it's proven to be valuable does it get a permanent spot in a trusted library of wisdom. Okay, so let's get into it. Here's our roadmap for today. We're going to meet the three core components first. Then we'll follow an idea on its complete journey, from the observation diary, through what I'm calling the quality gauntlet, into the library of wisdom, and finally we'll see how that knowledge stays up to date. All right, first up, let's meet the core trio that makes this whole learning engine tick. Don't worry about the acronyms just yet, we're going to break them all down. They are the Lightweight Candidate Journal, the Agent Learning Pipeline, and the Phenomenological Knowledge Store. Everything, and I mean everything, starts its life right here in the LCJ, the Lightweight Candidate Journal. The easiest way to think about this is as the agent's personal diary. It just jots down everything it does and sees online. Every click, every error message, every little change, with absolutely zero judgment. This is the raw material. Next up is the ALP, the Agent Learning Pipeline. And honestly, this is the real star of the show. If the LCJ is the diary, the ALP is the Intelligent Quality Control System. It's the gatekeeper. It sifts through all those diary entries, analyzes the raw data, and makes the critical call on what's actually valuable and what's just noise. And finally, we've got the PKS, or Phenomenological Knowledge Store. This is the agent's long-term memory, that library of wisdom we were talking about. And believe me, this is a very exclusive library. Only knowledge that has been rigorously vetted and approved by the ALP gets a spot on the shelf. Once it's in, it becomes a trusted playbook the agent can use again and again. Okay, let's zoom in on that first stop. We're going to dive a little deeper into the starting point of all learning, the Lightweight Candidate Journal, the LCJ. So the LCJ is more than just a simple list. It's smart. For one, it groups related things together into what it calls activity sessions. And this is really clever. To avoid getting swamped with repetitive data, like if you click a broken button 10 times, it uses something called throttling to just bundle those identical events into one. This is so important because it keeps the whole system from getting bogged down and feeds clean, useful data to the next stage. All right, now we get to the heart of the system. This is where that raw data is really put through its paces. Welcome to the Agent Learning Pipeline, or ALP. I like to think of this as the place where a simple observation goes on trial to prove its worth. You see, in Nova, knowledge doesn't just get saved. It has to graduate. It has to work its way up through three distinct learning levels. It starts out as just an L0 candidate, basically an unproven hunch. If it shows some promise, it gets promoted to L1 shadow, where it's tested more. And only if it passes that stage can it finally reach L2 active status. Now, this is a really, really important safety feature. The agent will only ever automatically use knowledge that has reached that L2 level. Anything at L0 or L1 is strictly considered learning material. It's being watched and tested, but not acted upon. This is huge because it prevents the agent from running around acting on half-baked ideas or unreliable info. So how does an idea get that first promotion from a basic candidate to shadow mode? Well, it has to pass through these very specific, data-driven gates. As you can see, it needs a confidence score of at least 70%. It has to have been observed at least twice, and at least one of those times has to have been a success. If it doesn't hit all three of those marks, it's out, no exceptions. And if you thought that was tough, look at the final trial to get to L2 active status. The standards get even higher. It needs at least 3 successful uses, and those successes have to happen in at least 2 different sessions. It can't have failed more than once. And this part is genius. The website it's related to can't have changed in the last 7 days. It has to prove it's not just a fluke, it's both stable and reliable. Okay, so once an idea has survived this whole intense process, it finally gets to graduate. It's promoted into the agent's long-term memory, that exclusive library we call the Phenomenological Knowledge Store, or PKS. So what's in this library? Well, it stores these active L2 level playbooks and fingerprints. You can just think of them as proven step-by-step guides and recognition patterns. This is what lets the agent confidently handle a familiar problem, like dismissing a specific cookie banner, without having to relearn it from scratch every single time. But the story doesn't end there. Because on the web, things change all the time. What worked perfectly yesterday might be completely broken today, so that knowledge has to be kept fresh. And this brings up a massive challenge for any learning system, right? What happens when a site gets a redesign and that once perfectly reliable playbook is now totally obsolete? How do you stop the agent from trying to use outdated information and failing? Nova's answer to this is just so clever. It's a process called silent revalidation. It is constantly and proactively checking to see if its knowledge is still valid. And the silent part is the key. It does all this by running tiny, harmless scripts that just inspect the page without ever actually clicking a button, typing in a field, or changing anything you see. The process itself is just wonderfully elegant. First, the system picks some older knowledge that's due for a checkup. Then it generates a tiny piece of code to test if the key web page elements it depends on are still there. It runs that script silently in the background, and then it looks at the results. If those elements are gone, what the system calls drift, that piece of knowledge is immediately flagged to be demoted. You know, this quote really does say it all. The entire system, with all its fancy gates and levels and checks, it all boils down to this one simple concept. The ALP is the essential quality control that stands between a random observation and something becoming trusted long-term knowledge. So let's just quickly recap that whole life cycle one last time. It all kicks off in the LCJ, the diary, where a raw observation is born. From there, the ALP, our quality control gauntlet, puts that observation through the ringer. If it passes all the tests, it graduates to the PKS, the library, where it becomes active knowledge. And finally, silent revalidation works 24/7 to make sure it stays fresh. And all of this leaves us with a pretty big question to think about. As we start relying more and more on AI agents in our daily lives, how important is it going to be for them to be transparent, for them to be able to prove step by step exactly how they learned what they know? You have to wonder if a system like this one, with its clear, auditable trail, isn't the blueprint for how we're going to build that trust in the future.